So now we are going to do this problem using DIF technique. So presently we are doing this question 8-point DFT of x of n 0, 1, 2, 3, 4, 5, 6, 7 using DIF technique. And the answer is supposed to be got is this one. And as we have learned, we have to look into the basic concepts. So beginning with n, it is 8 here. So which means m will be equal to 3. If the 3 stages will be 8 point, followed by 4 point, followed by 2 point. 8 point will be done 1 time, 4 point will be done 2 times, and 2 point will be done 4 times. 2 raised to 0, 2 raised to 1, and 2 raised to 2. Moving on, we'll require the butterfly diagram. So the butterfly for DIF, as we know, the 12 factor lies here, W and K, and this is minus 1. If this is A plus B, this will be A plus B here, and this will be A minus B, W and K. Then we need the 12 factors. So the 12 factors required are as follows: W80, W81, W82, and W83. So we all know W80 is equal to W40 and W20, which will be equal to 1, and W82 will be equal to W41, which will be equal to minus I. We need to obtain W81 and W83. So we have obtained the 12 factor as follows: W81. So basically you all know that WNK is computed with e raised to minus j2 pi into k by n, and that's how we compute this thing. So W81 we have obtained over here. It's 0.707 minus 0.707i, and W83 is minus 0.707 minus 0.707i. And last we have to know about these input. So input will be in normal order and output will be in bit reversed order. So with these we begin the question and we are going to solve it. So we have to write the input in the normal order. So this will be 0, 1, 2, 3, 4, 5, 6 and 7 in the normal order, and we have to connect to this is the third arm, this is the fourth arm, this is 1, 2, 3, and this is the fourth arm. So we connect just to avoid confusion, I've drawn that. Try to draw a straight line between these two. Then we connect these two. Then we connect these two. Then we connect this two. So we have the minus 1 factor here. We have the minus 1 factor here, the minus 1 again over here, and then the minus 1 over here, and this will be having the 12 factor W80. This will have the 12 factor W81. This will have the 12 factor W82, and this will have the 12 factor W83. Now moving on, when we solve this particular thing, we can solve the first one without much difficulty. We'll look into it. So when we solve this particular problem, we get when we solve this butterfly, we have 0 and 4 at the arms. So A is 0 and 4, B is 4. And when we have over here, we have 4. And at this point, we'll have 0 minus 4, that is minus 4. Into W80 is 1 again, so it will be minus 4 itself. When we go for solving this arm, 2 and 6 over here, so that would be a bit complicated, so let's try that out. So we have the butterfly over here. 2 and 6 are the 1 and 6 are the signals involved. 1, and we have to solve for 1 and 5 again. Note that we are presently solving the second butterfly, where we have the inputs as 1 and 5, and we have the 12 factor as W81, and we have the minus 1 factor. So this will be like 1 plus 5 equal to 6, and this will be minus 4 into point W81 is 0.707 minus 0.707 I. We'll just solve it. Minus 4 into 0.707 minus 0.707 I, so which will be like minus 2.828 minus point, this will be like plus 2.828 I. So we'll place it over here. So we'll have 6 here, and we will have minus 2.828 plus 2.828 I as the second output. Then we have to consider the next butterfly. So I'll be wiping off the. So we are going to do the third butterfly of the 8-point stage over here. So we are going to solve that butterfly. We have the diagram over here. The twiddle factor is W8082, and the signals are 2 and 6. So essentially this wouldn't be difficult. So this will be A plus B equal to 8, and this will be A minus B minus 4 into minus I. W82 is minus I, so this will be like 4I. So the signal over here will be 8, and this will be 4I, and then we have to solve the next butterfly, which will be minus 1 and W83, so that will be like 3 and 7, so the output is like 10, and minus 4 into W83 is as we had written earlier, it is minus 0.707 plus minus 0.707 I, and the output will be like plus 2.828 plus 2.828 I. So we can write it over here. So this will be 2.828 plus 2.828 I. So that completes stage 1 of the operation. Moving on, we'll do the stage 2, and for that we are clearing off this solving that we had done in this space. So the 8-point DFT was computed, and right now the second stage that we have to implement is the 4-point, which has to be done connecting the two forearms together. So we have 1, we have 2, we have 1, and we have 2. So this arm will be connected to this one, and this arm will be connected to this one, and it says the second arm, second butterfly, we are connecting this with this and this with this. So the twiddle factor here is W40, twiddle factor here is W41, the twiddle factor here is W40, and the twiddle factor here is W41. So this will be minus 1 right here, and again you will have minus 1 and minus 1 out here. So we have to solve this particular thing with the input as this one particular set. So we'll have let's easily solve the W40 equations. So we are choosing the second butterfly of the first 4-point DFT. So we'll draw the diagram out here. The inputs are 6 and 10, and we have the minus 1 factor. We had W41 out here, and this will be like 16, 6 plus 10, and this will be minus 4. That is 6 minus 10 is minus 4 into minus I, resulting in 4I. So we have 16 and we have 4I out here, and then we have to solve the next butterfly out there, which is a bit exhaustive in terms of calculation, but which requires clear attention while solving it. So the input at this point is minus 2.828 plus 2.828i, and here you have plus 2.828 plus 2.828i. So comparing these two terms, the sum will be this term and this one will get cancelled when they are added up. So it will result in 656.5 I, and at the bottom we'll have the subtraction of this thing. When we subtract these two terms, it will become minus 5.656 into minus I, so it becomes plus 5.656 I. So at the bottom arm we have 5.656 I, and at the bottom arm again we have 5.656 I. Now we are proceeding on to the last stage, which will be the 2-point DFTs, which will be done 4 times. So we are connecting this, then this, then this, and this is the last one. So we have the 12 factors W20, W20 out here, again W20 and W20. We will have the minus 1 factors. So solving this with these input, the results will be drawn quickly, as we have very short time. Solving this would be an easy affair, and all you need to do is add the terms and subtract the terms out over here. So 12 plus 16 is 28, 12 minus 16 is 4, minus 4 plus 4i will be minus 4 plus 4i, and minus 4 minus 4i will be like that. And then you do the same with these terms and you are able to solve this particular thing. We have obtained these results out over here, and we know that the output will be in the bit reversed order. So this is position 0, so when you bit reverse it, it will be 0. This is temporarily supposed to be 1, the first position 0, 0, 1. When you bit reverse you get 4. This is 0, 1, 0, again 2. This is 3, that is 0, 1, 1. When you bit reverse it, it becomes 1, 1, 0, 6, and 1, 5, 3, and 7. Again, if you look over here, you have x of 0 as 28, x of 4 is minus 4, x of 2 is minus 4 plus 4j, and x of 6 is minus 4 minus 4i, and this can be verified. Hence you have got the correct result, and all you need to do right now is write the result in the correct order, which is not the way that you have received your output. It has to be written in the correct order that is given over here. So that I hope clears the example of 8-point DFT calculation using DIF FFT technique.